In this video, we will try to understand the Sn2 reaction, that is nucleophilic substitution reaction. It is called Sn2 reaction. So before getting into the reaction details, we will study the important terms which comes in this reaction. One is nucleophilic. Okay, that is a reagent that brings an electron pair is called a nucleophile. So that is nucleus seeking, and the reaction is called nucleophilic. So this is negatively charged and it will be looking for a nucleus positively charged. So this we will understand with an example. So hydroxide ion, I can write this way or this way, and negative charge is on the oxygen. So let me give the details. Electronic dot structure. I'll take oxygen. Okay, 1 2 3 4 5 and one more electron I'll put here. Oxygen will have 6 electrons. So one electron is bonded with H and one more extra electron is there. That's why it is negatively charged ion. So this is represented Nu with a colon. Okay, so it is a negatively charged ion and it is seeking for a nucleus. So then substitution reaction. This is very simple. When an exchange of element takes place in the reaction, then it is called a substitution reaction. So here I am going to explain with an example. The same example I will take. So I will take hydroxide ion plus chloromethane CH3Cl. This will give CH3OH methanol plus negative chlorine ion. Okay, so for your this one I will write the details. Hydroxide ion plus chloromethane methanol plus chlorine ion. Okay, so this, to understand the reaction clearly, let us write the dot structure for few compounds. So oxygen I will write again here, already I explained. H, this I will write this way. Okay, chlorine, so here chlorine has got 1 2 3 4 5 6 7 electrons, and this is the carbon electron. Okay, then this will give you CH3OH. so OH I will write this side. So carbon, it has got 3 hydrogen atoms and plus chlorine atom 1 2 3 4 5 6. That's why it is chlorine minus, and this is HO minus. Okay, so this is substitution reaction. So when an exchange of element takes place in this reaction, okay, oxygen is coming here, chlorine is going out. Bimolecular. So bimolecular means in the second order kinetics, if the reaction rate depends upon the concentration of both reactants, is called bimolecular. In this reaction, hydroxide ion and chloromethane concentrations are required to calculate the concentration of methanol. So these two reactions are important here. Means equations are required. So that's why it is called bimolecular reaction. Because of these three names, nucleophilic substitution reaction name came. Okay. Not only this, we will study further in this stereochemical based mechanism also. For that, two terms are necessary. That also I'll explain now. Okay. So the optically active molecule. See, molecules, some molecules, the incoming light, it will change the polarization. That is, compounds rotate the plane polarized light when it is passed through their solution. See, liquid crystal display does the same thing. So for this to understand, let us take what is the plane polarized light. This is the plane, like you can take earth surface. Suppose if any wave is coming parallel to this, okay, if you are standing here and if you see, you will see this portion here, and sometimes wave is coming this way, sometimes wave is coming this way. So this is called plane polarized wave. Plane polarized wave, that is light wave. Okay, so if you pass this through this optically active molecule, what happens is it will get rotated. It will become vertically polarized. So this is actually horizontally polarized. Okay, so now here if you see, this is like a wave, the seashore, sea wave coming towards you. You will see water going up, coming to the center and going down. So this is horizontally polarized, this vertically polarized. If you give this wave to this molecule, it will convert this into this wave. So it will rotate 180 degrees. Correct. See, the rotation can be two ways. You can do like I'll write here. This is vertically polarized wave, horizontally polarized wave, that is plane polarized wave. This can be, this you should see like this horizontally is in the plane. Okay, if it is rotated, if this entire thing, if you rotate 180 degrees, that means parallel to the ground you have to rotate. Okay, like pen like this, and then you rotate. Okay, if that way if you rotate, then this for this anti-clockwise positive sign is given. If it is clockwise, if you rotate from this way to this way, if you rotate, okay, then it is clockwise is negative sign. Okay, so it can rotate 180 degrees in either ways. Okay, so this is optically active molecule. Other one is molecular inversion. Here I will write one example and explain. So let us take one compound. So it is like this. This is CH3. This is X. This is C2H5. Okay. And hydrogen is away from you. This is towards you. This, if it gets rotated like this, this remains same because horizontally you are rotating. So why this will come this side, this CH3 will come here, H will go here. Okay, so this is why. So rotate the compound or molecule 180 degrees with respect to the center of the atom. Center of the atom, if you rotate, then it is called molecular inversion. Here you have to understand different way. Molecular inversion happens, actually it is 180 degrees rotated, not the entire thing. See, whatever, this is X. After the chemical reaction, the Y is occupied this position, but this is 180 degrees away. Other things remains as it is. So that way you have to understand. It is not similar to the optically active molecule. So rotate the compound molecule 180 degrees with respect to the central atom in the 3 dimension. Okay, here mainly the before the chemical reaction, X was here. So after the chemical reaction, it is rotated like this with a with the new replaced compound or replaced molecule. It has come here. So this way you have to understand. Okay. As I mentioned earlier, there are two types of mechanisms for Sn2 reaction. The first one is Hughes and Ingold proposed mechanism, and second one is stereochemical based mechanism. So the fundamentals required for this already explained. Now we will take up the actual reaction. Hughes and Ingold proposed mechanism. The definition I will read. A nucleophilic substitution in which the rate determined step involves two components. Sn2 reactions are bimolecular with simultaneous bond making and bond breaking steps. So it has got 3 points as we discussed earlier. So it is a nucleophilic substitution reaction. So nucleophile will come and it will get substituted, and the other one will go away. Then the rate determining step involves two components. Two components means two chemicals are involved. Two reactants are involved. Sn2 is bimolecular, that is bimolecular, with simultaneous bond making and bond breaking. Anyway, I'll explain with the example, same example. I'll write again. OH minus CH3Cl, same thing whatever I have taken. CH3OH plus Cl minus. Okay. This I already elaborated. Let me write once again here for understanding purpose. Cl, then OH comes to the carbon atom and chlorine will go away. So this I will write in a still better way. So you take HO plus this, we will take one H on this side, chlorine on this side. This is another H. This is another H. So the same thing I represented in 3 dimension. One H is coming towards you, other one is going away, and other one more H is there and Cl is there. This one, the intermediate step I'll write here. That is center carbon atom. H, here Cl is there, here HO will come, and so this is the H, this is the H which is going away from you. Okay, this is intermediate step. Here I have included intermediate step. Then this is the final one is HO will come this side, H, another H, one more hydrogen atom here, and chlorine will get separated. So here, so the steps are like this. I will read and explain. The incoming nucleophile interacts with alkyl halide, this alkyl halide, causing the carbon halide bond to break while they forming the new carbon OH bond. Okay, this bond breaks and this bond forms. Okay, so these two things happen simultaneously. When it happens simultaneously, this HO to carbon atom will become stronger and stronger. carbon to chlorine atom becomes weaker and weaker. And see here, it has got carbon, center carbon has got 1, 2, 3, 4, 5 covalent bonds. 5 covalent bonds is not possible with carbon. So this is an intermediate step. Like you cannot separate this when the chemical reaction is happening. So this is just for the identification or for explaining purpose, and this kind of mechanism happens. Afterwards what happens? This will get bond completed and this will go away. When this is going away, it will take 1, 2, 3, 4, 5, 6, 7, and this electron also it will take away. So that's why it will become negative. Whereas this will bring that electron. This has got an excess electron, so it will bring here. Okay. So that's why this is getting negative. So this process is represented with an umbrella. Let us write the umbrella here. Let us take one umbrella. Okay. Assume that OH electrophile is coming like a wind. Okay. If wind is too much, what happens? Umbrella will turn upside down. So let us rightly draw upside down. Too much of wind. OH is like a wind. It has come and it has disturbed this. This is nothing but CH3Cl. Now this OH has got attached. So it has become CH3OH and chlorine is blown away. Okay. So this process is called inversion of configuration. Okay. So that is, chlorine was this side, but after the reaction, HO has come this side. So that is the inversion of reaction. Okay. This state is unstable. Okay. This is Sn2 mechanism in terms of Hughes and Ingold method of explanation. So now we will go to the other explanation. So in this stereochemical based mechanism, I already explained you the optically active molecule and molecular inversion. With these two things I will explain here. Stereochemical based mechanism, it is called backside attack. The nucleophile approaches the molecule 180 degrees from the CX bond, already we discussed, and as the C nucleophile bond forms, C leaving group breaks away. So here I will take a different example and explain. This example I have taken from NCERT book. Okay, so let me draw the book, equation. HO minus, okay, if it is coming, this is I have taken C8, H17 PR. Okay, this is 2 bromo octane. Okay, it is, I'll write this CH3 Br. This is chain C6 H13 and H. It is like this. C6 H13, the chain is facing you, H is the other side, then it has got CH3 and Br. If this reaction, Sn2 reaction happens, what happens is this central atom CH3 will go here, this chain will come C6 H13 CH3 HO H plus Br minus. So this side, this is C8 H17OH this is octanol, okay, is octanol. 2-bromo-octane becomes octanol. So here, whatever I discussed earlier, whatever I explained, two things are happening. See, both are optically active molecules. Optically active molecule is also optically active molecule. So that means it converts plane wave into vertical wave. Okay, so both will do that. Okay. Now we will see the molecular inversion. See, molecular inversion also happened. That is, here Br, instead of Br place HO has come. Only these angles are different. Otherwise, molecular inversion happened. When molecular inversion happens, if this is anti-clockwise rotation type, that is anti-clockwise rotation type means positive. Then after this operation, after this chemical reaction, what happens? This will become clockwise rotation type molecule. So clockwise rotation is minus. So imagine it does 180 degrees, but this will do in anti-clockwise way, anti-clockwise rotation, optically active molecule, but it is anti-clockwise rotation type. Because of this Sn2 reaction, we have got a new product that is again optically active molecule, but the rotation here is clockwise rotation. This matters. Okay, so this way also we can explain optically active molecules, the rotation is changed from anti-clockwise to clockwise. This is also another explanation of Sn2 reaction. Okay. In my next video, I will solve some numericals of Sn2 reaction.